Hello and welcome to a new series of rambles. We are focusing for the next few videos on the department's paper 2 from November 2023, and we are kicking off the series with question 3. Right, in the figure we have L with the given coordinates, S and N. They are the vertices of a triangle having SLN as 90 degrees, a right angle. So SL is perpendicular to LN. LN intersects the x-axis at K. Okay. Right. Calculate the length of SL. Leave your answer in third form. Okay, so that is, we are starting out with some good old basics using the distance formula, right? So SL will be the square root of, let's do x coordinates, so 4 minus 4 squared, and then let's do y coordinates, 5 minus 1 squared. Right, so then that is, and leave in third form by no means means doesn't mean you have to do it the calculation manually. You can just, at least all you have to write down is this bit, at least, to show that you know the formula, and then you can just punch it into the calculator, and the calculator should give it to you in third form. But you know me on this channel, there's a bit of an allergy to calculators now and again. So anyway, so that's 4 plus 4, which is 8 squared is 64. This is 4 squared is 16. Add those together, we get 80. And okay, let me not be stingy with space. So that is 16 times 5, which is, the square root of 16 is 4, and then, right, so then this is our answer. It will be 4 root 5 units. Okay, so now I wonder if I'm going to be able to move these. This dark mode I'm very excited about, because it is potentially going to help me know where the boundaries of the pictures are, and I won't keep moving them by mistake when I'm trying to move a calculation. Right. Okay, so that's good and well. Right, so then the next question asks us to calculate the gradient of Sn. So this is again just plug into a formula question, right? We've got our 2 points, the coordinates are given to us, so we can just calculate the gradient of Sn will be the y coordinate, or we can start with S, y coordinate of S minus y coordinate of N, and then x coordinate of S minus x coordinate of N. So that's 5 plus 3 divided by 4 plus 2, which is 4 over 3. Okay, so you can also come down here, my friend. Okay, and then the last question asks us to calculate the size of theta, the angle of inclination. Inclination of Sn. Right, so this is easy enough to do because we have the gradient of Sn from the previous question. What is happening with my words on this beautiful day? Anyway, so we can use the formula that says the gradient of Sn is equal to tan of its angle of inclination. So the gradient of Sn is equal to tan theta. So gradient we worked out to be 4 over 3 is equal to tan theta, and therefore theta will be the inverse of tan. Because our tan is positive, we know that we're dealing with an acute angle, so we can just put that in with no further complications. Right, and that gives us about 53.1 degrees as our theta. I am loving this dark mode situation. It is making me so happy. Anyway. Okay, I didn't really need to shrink that one, but anyway. Right, let's just check with the memo that we're on the right track before we go too far with these figures. And we are in agreement. Awesome. Except that they are rounding off to 2 decimal places. So 53.13 rather. Right, on to the next question. Calculate the size of LNS. Okay, so there are a couple of options that come to mind. By couple, I literally mean two that come to mind. First, I think, okay, we can probably do a bit of angle of inclination, sorcery, wizardry, to eventually figure out the size of this angle. So let's just see. Yeah, by knowing this, the size of this angle, we know the size of this angle. And then, okay, let me just write this down as we go because my working memory space is quite limited, as it turns out. Anyway, so we can, so we know the size of that, and then we can find the size of this by finding the angle of inclination of this line, which in turn will allow us to figure out the size of that because angles on a straight line. And then, and we don't even need this one, honestly. We can just then use exterior angle of a triangle. These two must add up to that. So that's one approach we could take. Another approach we could take is, well, we've got a right angled triangle, so we can use our SOHCAHTOA. Possibly. We've already worked out the length of SL, I think, in the first question. How did we work out the length of? Yes, the length of SL. And then from there we could work out the length of the hypotenuse, we could work out the length of this guy, and then use one of the trig ratios to figure out this angle. Which one am I gonna go with? I'll do both. So let's go with approach number one. Let's use our trig. Okay, so in that approach we know that SL is equal to 4√5. Okay, and we are looking for this angle. I mean, really potato in terms of which side to whose length we need to work out. Let's go with SN. So SN is equal to, so it will be 4 minus 2. And this is a difference we've worked out for the gradient, actually, these differences that I'm working out now. But anyway, 5 minus 3. And then we'll have 4 plus 2 is 6 squared. And then 5 plus 3 is 8 squared. Well, square roots of mine are always just incredibly long. Okay, so that is the square root of 100. That's nice and cute. So SN is 10 units long. Okay, just randomly throwing okay, just to make this clearer for myself. Did that highlighter highlight? Oh my goodness. Wow. Is this guy? Is it highlighting? Am I dreaming? Is that highlighting? Oh, interesting. Is it not gonna highlight on the picture? Oh, flaws in the system. Oh, it's just not very visible. No, I am confused. Oh wow, okay, I might not be a fan of dark mode after all. Crashing through the snow. There was a cool trick I learned while I was experimenting with other things. I can draw straight lines like that, y'all. Just like that. I'm a magician. Okay, some of these straight lines are not really giving, but anyway, it was worth the effort. Right, okay, so now we have the opposite side, the hypotenuse. We can use sine. So sine of theta will be equal to SL over Sn, which is 4 root 5 over 10, and therefore theta will be inverse of sine of that. Okay. Ja, wat gebeur? So that is 63,43 degrees. So that is approach number 1, using some trig. Right, and you could just have easily have calculated the length of this side instead and used cos, or you could have calculated this length and used tan. Up to you, up to you. Right, so let's duplicate this and use another approach. So let's use a ring. Yay, man! English. Oh, there's the highlighter. Oh, have I discovered a bug? Have I discovered a bug? Anyway, so let's use what are we going to use? Angles of inclination. Okay, so we'll have, so technically now I can use a very random color, like, because I feel like, let's just see what's going on with purple here. I mean, it's kind of visible, but it's not great. But I can use a ratchet color like yellow. Dark mode, I love you. Dark mode, I love you. Right. It's kind of giving Khan Academy, like, minus me being very random and not always great at explaining. Anyway, right, angles of inclination. So we said, first of all, we would want to work out the size of this guy. Well, we know the size of that guy, rather. So we know that angle KON is equal to theta, right? Because they are vertically opposite angles. Okay, and we know that that is roughly, I think it was 63, what? No. 63 was the answer we just got, right? So theta is 53,13. Right, so 53,13 degrees. Okay, so we know the size of that guy. Then from there, we are going to work out the size of this guy. Right, so angle LKO. So to do that, we're going to need to find the gradient, the gradient of Ln. Okay, so the gradient of Ln is 1 minus 3, our y coordinates, and then minus 4 minus 2. So that is 1 plus 3 divided by minus 4 plus 2, which is minus 2. It's negative 2. So then we know that tan of LKO is equal to -2. And then we need to get our ref angle, which will be inverse of tan of +2. And that is roughly 63,43. Hey man, this is what we just got. Oh, yeah, yes. I'm so confused. Okay, right. Cool. So therefore, LKO will be 180 minus that, so it won't be equal to it, it will be approximately that, right? Right, and that is 116,57 roughly. Right, and then so now we have that angle. Okay, now we need to shrink stuff. Okay, so we now have that angle, we have that angle, so we can now, get in here. Okay, and to do that, we are going to use exterior angle of a triangle. So angle LNS will be equal to angle LKO minus angle KON. Right, and just to highlight what is what, angle LKO is the orange one, and angle KON is the blue one. Okay, right, and the reason why these are equal is because of exterior angle of triangle KON. Right, so that is going to be equal to the 116, in fact, this rounding stuff is only really a problem because I'm not doing what I usually do. I usually write my dots and then I don't need to put all these roundy stuff all over the place. Anyway, 116,57 minus KON, and what does that? I lost my other number. I lost my 53,13. I think it was just inverse of 10 of 4/3, right? Okay, and indeed, this comes to 63,43 degrees, as we obtained in the previous question. Okay. Right. I am moderately confused, I won't lie, because Oh, this was the sine. This, well, this angle has, I'm so confused. Why was I so confused? Okay, so clearly this angle has a sine ratio of this, and it has a tan ratio of this. It just caught me off guard to see this number, which is also the answer. It caught me off guard for some reason. Anyway, memo. Sorry. Yep, memo is in agreement. Oh, and this is an example of a place where using using the rounded numbers is a bit of a dribblish, because technically this minus this is equal to 63,44, which is what the memo has. But 63,44 is, if you're using the rounded numbers, but if you actually use the pure numbers unrounded, you get 63,43 or something closer to 63,43 than it is closer to 63,44. Anyway, so just pretend that this makes sense, but it doesn't. Okay, right. Next up, determine the equation of the line which passes through L and is parallel to SN. Okay, so it's gonna be a line. Well, let me do this. Well, let me get my ruler rather. So rotatey, and would you look at that? 53 degrees on my ruler. These things are actually really often drawn to scale, aren't they? Anyway, okay, so you can see that 54 doesn't quite fit right. 53 also doesn't quite fit right. It's because it's meant to be 53,1 something. Anyway, so we want a line that is parallel to this guy, but it must pass through L. Right. And we want that equation, the equation of that line. So we know the gradient of that line because we know the gradient of this line. So we know that the gradient will be equal to, okay, that's not really visible. So we know that the gradient will be equal to the gradient of Sn, which we calculated to be 4/3. So the equation of the line is going to be something like this. And then to find the C, we're going to sub in this point that we know lies on the line. So sub in the point L. So we know that 4/3 times -4 plus C is meant to give us 1. So that is -16/3 plus C is equal to 1. And that will be, well, 1 is the same as 3/3, so we would have to add 19/3 to get +1. Sorry, so C is equal to 19/3. So the equation of the line is y is equal to 4/3x plus 19/3. Memo, what do you think? The memo agrees. Perfecto. Right, next up. Calculate the area of LSN. LSN, the triangle, of course, the triangle. We know the length of that is 4√5, I think. And I did a moomish. So we know that that's 4√5. And we calculated that this is 10. So I'm saying I did a moomish because in that other question where we were working out the size of this angle, if I had calculated the length of this instead, then I would have had my base and height now that I can just type together and get the area. But unfortunately the foresight was dololo. So okay, so I have options, right? I could either go ahead and calculate the length of this and then do my half base times height, or if I really want to force matters, I could work out the size of this angle. So using cosine, right, I can work out the size of this angle and then use my trig area rule. That works too. But yeah, distance formula, man, hey, just makes me nyama nyama, man. Let me just work out this angle, as long as you know that the options are there. So cos of angle S is equal to adjacent over hypotenuse. So therefore S is equal to inverse of cos of this, which is equal to so it'll be 26,56 blah 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 degrees. Okay, so therefore the area of the triangle will be equal to half 4 root 5 times 10 times the sine ratio of the included angle, which is 26,56 blah 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 degrees. Right, that guy over there. Right, so let's calculate that. Okay, so say 0.5 times 4 root 5 times 10 times sine. Nice, sweet number, 20 square units. Okay, and if you did the distance formula road, you should get the same answer. Well, supposing that I am correct, and I am correct. Whoop, whoop. Yeah, the memo went the distance formula road. I miss me. Okay, right. 3.7, calculate the coordinates of point P, which is equidistant from L, S, and N. So there is some point P, let's say somewhere here, such that the distance to each of these points is the same. So let's say the point P is here, then the distance to this is 1, and this is also 1, and that is also 1. It doesn't look like it, but well, the distance is 5 and 5 and 5 or whatever. So that's the point P we need to find. So I say a little prayer and hope my dreams will take me there, where the skies are blue, to see you once again, my love, overseas from coast to coast, to find the place I love the most, where the fields are green, to see you once again, my love. Right. So what we are looking for is the point P. Okay, so let's say the point P has the coordinates A and B, right? Then what we need is space. We need, oh, let's see how gray looks. We need, yeah, okay, we definitely shouldn't have black anymore. Oh, what can we replace black with? So we need SP to be equal to LP to be equal to NP. Right, so SP would be 4 minus A squared plus 5 minus B squared. LP would be minus 4 minus A squared plus 1 minus B squared. And then lastly, NP would be minus 2 minus A squared plus minus 3 minus B squared. Okay. So let's just look at one of them. So, I mean, technically there's 3 sets of equations, right? SP must be equal to LP, LP must be equal to NP, SP must be equal to NP. But transitivity applies. If SP is equal to LP and LP is equal to NP, then it follows that SP is equal to NP. So it's actually just 2 sets of two equations we need to solve simultaneously. So we need that to equal that. As for why I'm writing this out again, there's no need to go. So that is equation number 1. And then equation number 2, we need, this is probably why I was just writing it out, to avoid all this drama. We need that to equal that. Okay, let's get a solving. So, I mean, this can only be true, seeing as we're only dealing with positive square roots also. That isn't a necessary disclaimer. Anyway, this can only be true if this is equal to that, or we can just say we're squaring both sides of the equation. But yeah, potato, 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 potato. Okay, so we need this to equal this. Okay, and let's just multiply this out. So we then have 16 minus 4a minus 4a plus a squared plus 25 minus 5b minus 5b plus b squared. And then on this side we have minus 4 times minus 4. Minus 4 times minus a is plus 4a, and then another 4a, and then minus a times minus a is a squared. And then we have 1 times 1 minus b plus b squared. Okay, so now we've got a squared on both sides, so we can just remove it from the scale. We have b squared on both sides, so we can also remove that from the scale. So now the left hand side simplifies to 41 minus 8a minus 10b, and the right hand side will simplify to 17 plus 8a minus 2b. Right, so let's get all our unknowns onto one side. So if we just minus 8a and plus Okay, and then the constant can also go. So we want the constants on the right hand side. So I'm going to get rid of the 41 on the left. So what do we now have? We now have negative 16a minus 8b is equal to 17 minus 41. That is 20 minus 24. Yes. Okay, right, and we can divide through by divide through by negative 1, because I don't like negativity. Oh, we could actually even divide by a common factor of negative 8 instead. Kill 5 birds with one stone. Okay, so that is going to be positive 2a plus b is equal to positive 3. So that becomes equation number 3, right? Simplified form of this equation. Okay, then let's do a similar thing. Wow, that took a lot of time. Let's do a similar thing for our second equation. Calculator is in the mix. Oh, guys, I have no peace. Wherever I look, I'm just being tormented. I don't know if this is... Oh, it got everything. It got everything, guys. In. Okay, so I'm just going to park this here and shrink it a little bit more so that I have a bit of space. Okay, right, so now we are going to do a similar thing for this guy. So using equation 2, okay, we need this to equal this. That's the only way that the square roots can be the same and have the same value. Okay, right, so multiply it out. We have already multiplied this out. Okay, so let's just use that. That ended up being this. Yes. Okay, that might be unnecessarily big, but anyway. And then the other side multiplied out, so that is going to be minus 2 times minus 2 minus 2. So that will be positive 2a plus another 2a, and then a squared, and then minus 3 times minus 3 plus 3b plus 3b plus b squared. Okay. Oh, snap. Oh my goodness, sorry. Iyo nayo. I'm so silly. This multiplied out does not equal to this. This is only after we cancelled. What's the difference between... Oh, hectic, okay. This is only after we cancelled out this, so it's actually equal to this. Oh my gosh. Jammer toch, jammer. In my defense, oh, there's no defense. Can't defend silliness, man. Can't defend it. Right, so let me get this one. Actually, let me try this freeform situation and see if it gives me joy in life. Okay, so now how do I move it? I can't move it. Interesting. Oh, but now I can't resize it. Oh gosh. Okay, anyway, so here we are. Right. So now again we can cancel our a squared on both sides, our b squared on both sides, and we can simplify this to 17 plus 8a minus 2b like we had, and then on this other side we'll have 13 plus 4a plus 6b. Okay, so similar process to before. I want my variables on the left, so I'm going to get rid of them on the right. So minus the 6b, do the same here. And then I'm going to get rid of my constant on the left. And then do the same on the right. Okay, so now we have 8a minus 4a minus 2b minus 6b. And over here we'll have 13 minus 17. Okay, and then we can divide through by don't need a bracket. Divide through by 4. So then we have a minus 2b is equal to minus 1. And that will be our equation number 4. Yeah. Siya jima, algebra. Right, so we now have two equations that we are solving. We have a minus 2b is equal to minus 1. Okay, and 2a plus b is equal to 3. And you guessed it. What approach am I going to use? I will use elimination. So I am going to times equation number 4 by 2, so that we get 2a minus 4b is equal to minus 2. And then equation number 3 looks like this. Okay, so at this juncture we can now minus. So 2a minus 2a is no a's. Minus 4b minus b is minus 5b. And then minus 2 minus 3 is minus 5. So b is equal to 1. So then we can sub b equal to 1 into any of our equations. I choose number 3. So then we have 2a plus 1 is equal to 3, meaning that 2a must be 2, and therefore a is equal to 1. Oh wow, so they're both equal to 1. And just to double check, 1 minus 2 times 1, which is 2, 1 minus 2 is indeed equal to minus 1. Yeah. Okay, so what was the original question? We even forgot. The original question was to find the point P, which is the same distance from L, N, and S, and the A and the B represent the X and the Y coordinates. So the coordinates of P are then 1 and 1. So my P is not here really, it's somewhere here. Okay, right. Doesn't even have to be in the triangle. I don't know why I'm forcing so much for it to be in the triangle, but okay, yeah, it could be here for all we know. Righty. Lots of M's. Let me shrink this so that I can fit my conclusion in here. Okay, so in conclusion, the coordinates of P are 1 and 1. Memo, if you don't agree with me, I will be distraught. The memo agrees. Oh, what an interesting approach. Okay, so my approach featured, which is fantastic. Hehe. Right, so that's one approach. But another approach says L is equal to 90 degrees. We've been told this. SN is a diameter of circle SLN. So if we were to draw a circle, oh, my circle is so bad. But okay, try to understand. Oh my goodness, this is so revolutionary. Ah! Right, so if we were to draw a circle, that circumscribes this triangle, right? Then this would be the diameter because of this angle being 90 degrees. And then from there, what do we do? Then it says the center of the circle. P would be the center of the circle. Oh, because SP and PL and PN would all be, they would all be radii. So your P would actually be somewhere here. So that this and this and this are all the same distance. I mean, that's what a circle is, right? It's a collection of points that are equidistant from a given point. In this case, our given point would be P. Right. So then, to find P, we would just find the midpoint of this line. Oh, that's such clever thinking. My goodness. So is it true that for any given 3 points, there will always be a circle going through them? It makes sense to me. It makes sense to me that they would. Visually, it feels like there would be. I don't know. If anyone has an explanation for that, holla. And of course, if I stumble across an explanation for why that is, I will share. Anyway, right, so what's up? I'm leaving. Oh, we're not done. We have one more question. Yo, even exiting the app. Okay, we have one more question. Calculate the size of LPS. The P from the previous question. You? LPS, the angle, that angle. Oh, but this is L and P are on the same horizontal line because they have the same y coordinate. We are looking for the size of this angle. Okay, but we know that these are parallel. Okay, meaning that we know the size of that because alternate angles on parallel lines are equal, and we know the size of this guy, and then we'll know the size of LPS from there. So that's easy enough. Okay, so let's say it. So we know that LP is parallel to the x-axis. Okay. And so therefore angle LPO is equal to theta because of alternate angles on parallel lines. LP and the x-axis are parallel. Yo, spacey, siyaphela. Okay, which is, well, let's just say 53,13 blah blah blah, which we found in somewhere in question 1. Okay, then therefore LPS will be 180 degrees minus LPO because angles on straight line. So that will be, sorry, 180 degrees minus 53,13 blah blah blah, and that is roughly okay. So now I need to, I think it was shift 10 or 4/3, right? And we need 180 your way. 180 minus that, not 180 plus that, 180 minus that. So that is about 126,87 degrees. So that is that. I'm just trying to think, like, suppose, as my grade 7 science teacher would say, suppose that you hadn't noticed that P and L lie on the same horizontal line. How could you have gone about it? So we're trying to find this angle. So yeah, it's kind of hard to not see it now that I've put it this way. Maybe let me just position the P in a weird place so that I can try and trick my brain. Something like that. We're trying to find the size of this angle. So I could try to find the size of this angle by doing what? Yeah, it's tricky, man. Like, I feel like, okay, I could try to find the size of that angle by I mean, you could find the length of this using the distance formula, and you could find the length of this using the distance formula, and you could find the length of this using the distance formula, and then you could use the cosine rule to find this angle, and then you would find that angle. So let's go ahead and do that for the sake of completion. So oh, and PN and PL are equidistant, so we just need to work out the one, really. So it's 3 squared, 4 squared, so it will be 5, and we know that PN is equal to PL, or let me rather say PL is the same in length as PN, which is 5, and then we can work out the length of LN. We haven't yet, yeah. So the length of Ln would be 1 minus 3 squared plus minus 4 minus 2 squared. So that is 4 squared and 6 squared. No, minus 4 plus 2. Okay, so that's square root of 20, which is the square root of 2 root 5. Okay, so now we have the lengths of all the sides. So we can just quickly do cosine rule things. So this will be little p, little l, and little n. So we know that we want this angle, so we need a cos p. So we're gonna have p squared. Can we go back to white? P squared is equal to L squared plus N squared minus 2ln cos P. Okay, then we can rearrange it so that we have cos P by itself. So that will be P squared minus L squared minus N squared divided by minus 2ln is equal to cos P. And then we can just do some switcher rules because of that negative downstairs. So L squared plus N squared minus P squared divided by 2ln is equal to cos P. Okay, now we can put in our figures. So we know that these two are 5, N and L, and then P is 2 root 5. So 5 squared plus 5 squared minus 2 root 5 squared, and we don't even need the 2 root 5, honestly. We can just say root 20 so that it's very clear what the square is. And then here we have 2 times 5 times 5. Okay, and that is 25 plus 25 minus 20, and down here we have 5 times 5 times 2. Okay, so then cos P is equal to 30 over 50, which is 0.6. So P will be inverse of cos of 0.6, which is 53,13 blah blah blah. Okay, so now we have the size of this angle, and then to get that angle we'll just say 180 minus this, which is what we had before as well. So what is the name of the angle? LPS will be equal to 180 minus the 53,13 blah blah blah, which is roughly 126,87 as well. Okay, so that's how a possible approach you could have taken if you didn't cloak that actually this guy is parallel to this guy. You can use a bit of geometry to help you. Right, and this is, yeah, these are pretty much the options. They also have a circle approach. So is the circle gone? Oh, the circle is here. So if you want LPS, that's an angle at center situation, and given that we know this, right, from another question, we worked out that this was 63, something. This is an angle at the circumference from this chord, and then this angle here would be the angle at the center, which is double that. Very cool, very cool. So early in the paper, so much coolness. Okay, the vibration to my iPad did not treat it well. Anyway, thank you for coming along on this trip. I hope you had a good time. I hope you're loving dark mode as much as I am. I genuinely feel like Khan Academy must just employ me just because of dark mode. Just because of how beautiful dark mode is. I don't know how that qualifies me, but that's my CV and I'm sticking to it. Anyway, cool. Ramble done. Catch you another time for another chat.